let's get going. Maybe we talked about, Raquel, we postponed a couple of times, so maybe you want to cover the column stuff first, and then we can get into updates, issues, and stuff.
Cool. Yeah, hypercolumn shouldn't take that much time. I'm going to reuse what was there in that kernel. Let me just share my screen.
So while he's pulling it up, just to set the context, this is specifically focused on how to integrate hypercolumns into the dynamic unit, and dynamic unit is more, regenerating the image. And as we have discussed before, while Raquel is pulling it up, I think hypercolumn, the idea is to, if I recall correctly, is to go back from the end pixel to include all of the pixels receptive field and try to have that make a difference in the value of the pixel, if I recall correctly. And then as we go through the code, we'll probably understand how that actually works.
Internet is super slow.
No, that's fine. So is my recall correct that it's essentially, trying to bring in the entire receptive field of a pixel into play?
Yes, that's kind of the idea. Wow. Okay.
Before you start there, Raquel, were you going for a new world record? Are you going for a new world record for how many tabs you can have open?
Just one of my windows.
It's just one.
I try to segregate work.
Yeah, I thought I was, it's like, is there a buddy who is more forgetful than me? So when I saw him, I was happy. So I'm happy to see you in.
Yeah.
How much RAM do you have?
Yeah.
It survives. That's the cool part. I don't know why is it weird that.
No, because I have 32 GB RAM on my work laptop, and it starts slowing down. Okay.
Cool. Yeah, now let's kind of look into this. Cool. So we kind of looked at units last time, and this just adds on the hypercolumn part to that. Both of them together. You can have the unit separately, and you can have like hypercolumn separately. This just adds on more ways for you to learn. So, and it should learn more stuff in that sense. Obviously, it increases the weight, training time increases, all that stuff. So what exactly are we dealing with hypercolumns this is the idea. So you guys can look at this image, right?
Yes.
Yep.
Yeah, okay, cool. So you start with the image, you start convolving, downsampling, keep going down. So this is what you would look like if you were looking at like a normal ResNet. The only difference is that the whole idea with these hypercolumn stuff is that you're trying to look at the last layer. This is the one which will be the smallest, and taking a pixel on that and trying to correspondingly find the pixels at different resolutions all the way back to the original image. So that's what the column is. And to do that, now if you, let us say, start with a 224 by 224 image, run it through ResNet 18, come down to something like a 2 by 2 block. Now you need to match these 2 by 2 pixels to something on this 224 by 224 block. So all you do is take this 2 by 2, upsample it to a 224 by 224, and the layer before that will be like a 4 by 4. Do the same thing, upsample that to a 224 by 224 size. So now each of these resolutions at the upsample scale basically have one pixel that can run through all these layers. And that's what this hypercolumn thing is, this is what the algorithm kind of looks like. They're kind of using this with box coordinates, but the idea is you go down, downsampling this all the way. At intermediate layers, you basically do this you add this convolution, do an upsample, and now all these upsamples from each of these, wherever you decide to do, or each of these layers that you decide to do, will be of the same size. So in theory, you can add them back up. And it's basically like pixel-wise classification. That's what segmentation is. So that's again like looking at it in terms of the architecture. We can kind of look at it. I can find it.
So question, Rakan, so you actually end up doing this independent of the upsampling or independent of the encoding path in the dynamic unit, is that right?
Relation, actually, there needs to be no relation with respect to.
Sorry, you're cutting off.
This would be, sorry? Oh, is it better now?
Yes.
No. Let's do this.
Sorry, what were you saying about relation?
That's what I was saying. So there is no relationship with unit versus along with a hypercolumn.
So it's independent
if you
of
image as your serviceable image, right? Another technique. So if I'm understanding this right, it would be something like a ResNet versus an inception model.
Okay, so you're following a completely separate path, but just an independent upsampling path to go from an end pixel all the way back to the original image, but whichever pixels of that original image are in the receptive field of the pixel in the end image. But since you're doing, I mean, and maybe that's a simpler add-on, but I was just curious, since you're generating those pixels at every layer, you could potentially, and maybe it's more computationally complex, but you could potentially get those pixel values from the calculations that you're already doing on the encoding path. Is that right? I mean, in concept?
Yes, I don't think there's anything off in that. That's why I just wanted to say that these two are completely different things, but we can combine them together.
Okay.
Now, what you're saying is right, because the encoding path, in theory, if it's the same on your unit and on this, then you're basically repeating the structure for both, right? It's just that the
at least,
yeah,
on a per pixel basis, you're kind of doing, or many of the calculations that you would have done on the path up. Again, just to orient the path, the ResNet that when you use the ResNet, is that decoding or encoding? I get confused.
The real ResNet side is the encoding. So basically, you're trying to take this huge 224 by 224 image, and you're trying to encode it into a much smaller, compressed form of information.
Okay,
basically,
so that is encoding. Okay,
yeah, that is the encoding.
So then what I meant is the decoding path gives you back, because that's primarily upsampling or using from the input image, right?
Right.
So yes, I understand that this is independently done but as a concept, you could get those pixels from the decoding side and reuse but you just have to then go figure which pixels to use, which probably is more complex.
You mean from the encoding side rather than decoding side, right?
What I meant is, see, in the decoding side, you are again upsampling or directly taking in the value from the encoding side in order to regenerate the image at a particular resolution, correct?
At a unit, you're not doing either, right? You do both.
Yes,
because
you do both.
So
what I was saying was that you could, since you're doing both, you could just use one or both of, as long as in the hypercolumns, all you care about is the value of the pixel in the receptive field of the pixel that you are that you care about in the final image. Correct? That is, if you start with a pixel, say X in the final image, all of the pixels that contributed to X at the different levels of resolution, you want to include them in your column. Correct? Is my understanding right?
Right.
Sorry.
Can you,
You still there?
are you able to hear me now?
Yes. Yes.
Oop.
You break off
Okay.
or drop off for some reason. Michael, you there?
Yeah, I can't hear him anymore.
Yeah. It was choppy when he was talking earlier. There were times he's probably logging off and logging back in. Give him a minute.
He had too many tabs open. It just killed it.
Yeah, going for the world record killed him. Yeah, but actually, to Mehul's point, I mean, even I have felt that beyond a point, it just freezes too many other things that, and I don't know, maybe we just are correlating things which aren't related actually, but
Yeah.
but beyond a point, I get nervous.
I definitely think I notice a slowdown in my computer when I have too many open.
Yeah,
And if you go into the Windows Task Manager and take a look, Chrome just uses so much. So
yeah.
Yeah, same here. Mine begins to crawl, even though I work often on a desktop, but even that begins to crawl.
I got a decent laptop from work, like 1 terabyte SSD, 32 GB RAM, and the new Intel processor. But yeah, after a certain point, yeah, and they have all this semantic crap, like we have all this anti-security, the security software.
Yeah, that's and actually the antivirus stuff tends to impact a lot of things.
Yeah, it has to go and check every single file. Like, God damn it, stuff.
Yeah, on the root stuff and so on too. Yeah, I used to work for the Phoenix Technologies, which is the BIOS company, and it's kind of amazing the extent of control you have when you are at that level. Let's just say that 3-letter acronym agencies were talking to us to where, even though I was heading up all of engineering, the guys who were working on it, I couldn't talk to them.
Oh wow.
about what they were doing. All I can tell you is they were working on stuff where people could know what every single thing you're typing without you ever knowing they were on your system.
Oh my God. Oh shit.
Hey guys, sorry, I got kicked out.
It's the tabs, Rekul.
But I switched laptops. Cannot close those tabs. Let me start sharing again. All right. Sorry. Yeah, I can't pull my notebook up, so we'll kind of run through this code itself. That is on the Kaggle competition that we kind of mainly are using this kernel. I also built my code off this itself. So yeah, sorry. Did that make sense? Can I ask the questions that you were asking?
Yeah, and let's just go through and I'll. And how does it get combined, or combined meaning they're independent, but then they have to be stitched back together, I would think, right?
So what he does in this, if I'm not wrong, is you basically builds out the whole model. So you go from your input image, you go down the encoder side of the unit, you go back up the decoder side of the unit.
Right.
But then since you've built the left-hand side out, like you suggested, you can either use the encoder and then just upsample, and you just need to make your sizes right, and so you would get that back to the same size. You can use it that way, or what you could do, which is the way he has done it. Let's see.
Yeah, that so you have the unit which is encoding and then decoding to get back to the original size.
Right.
The edge columns is just taking for every pixel on your output, you go back to create a column that's the hypercolumn, which is the set of pixels at the various levels of resolution that contribute to the pixel in the final image, correct? So for every pixel, you'll have a hypercolumn.
Yes, exactly.
Correct. Yep. Now, so and then you could just say that for every pixel, you would have a hypercolumn of the same size because you're going through the same, layers of resolution. And now, how do you combine these set of hypercolumns with the unit?
Yes. Let me.
Some sort of generative model for drug discovery.
Oh. Let me pull this code up. Actually, let me share it from here itself. Are you guys able to see this code?
Yes.
Yep.
Okay, cool. So this is what I was kind of experimenting. This was from another competition, which was the salt identification one. There also someone has combined both the unit and the hypercolumn. So this is what basically what I was saying is you build your unit out. This is the stuff we've already seen, right? Each of these blocks is just going back up the decoder, and you're starting from the smallest size, and you keep adding and you keep going up the unit. Once you get this output of the unit, this in theory is going to be your segmentation map, right? So D1 is the segmentation map for whatever your input image was. So what one way to go about doing that is you take this D1 now as your input image, right? And these are the different pieces that you're scaling up in the hypercolumn. So you can see this would be the one which is like the closest to D1. So that's why the scale factor is like the least. And this is going to be like the smallest one, which is at kind of at the bottom of the decoder that you kind of scale up by a factor of 16. And all you're trying to do is just concatenate this. And that is where that kind of started. Instead of doing hand wavy explanations, let me just.
Yeah, but basically that's more of what I was talking about of can't you just extract from your decoder what you would like? So because that's what he's essentially doing here, right? At that scale factor, just take D2, which is from your decoder path, and then create, use that, right?
Right, yes, yes. But that's what I'm saying. This has nothing to do in relationship with the unit, because in the unit, the extra thing that you're doing is this cat, right? Where you're,
correct.
Yeah, which is not required for the hypercolumn.
Correct. But what I meant or what I was trying to get at was you can use what you are generating, which is the D2, the resolution that you are at, which is D2, and then just use that, and then the scale factor and upscaling, which is why you do the mode bilinear.
Right.
And that'll give you, for every pixel, as you go back, you're getting the receptive field at every level of resolution.
Right. So in other words, to kind of put it, Srinivas, would be like, this interpolation is mainly going to just deal with the scale factor, right? So the idea is that as you keep going up this hypercolumn, the key is to have it of the same size. Now, either you use the decoder or you don't use the decoder from the unit. The only thing that is changing is your number of filters, because cat is just concatenating on the filter dimension right here, right? So it's just that the number of filters, so which basically means your weights will be like a combination of these two at this layer, instead of, otherwise it would have just been E5, the number of filters on the encoder. Does that explanation kind of tie in with what you're saying? Does that make sense to everyone?
Yeah. I mean, yes. And then when you, so that F is...
that is basically the bottom of the encoder.
Right, but then you also concatenate it with the
left-hand side of the encoder that's coming in.
Right, but for the hypercolumn, you're doing it, that's the F, right? At the F torch.cat, then D1 F dot interpolate, sorry, the small f, not the capital F. The small f is the concatenation of your dynamic unit and the hypercolumns.
Right.
Okay.
So this F will again be the same size as that of your original image. I mean, this is bad convention that I've been using here.
Of the final image, right? Yeah. Okay. Got it. Okay. So you just combine the hypercolumns and concatenate them with the image at that
resolution.
Resolution.
So it's a very simple strategy.
Okay. Got it.
So this is why I was saying, like, I think another experiment for us to do is, since they have combined it, would be to separate them out, like do only dynamic unit, that we have already done using FastAI. Now the question would be like to remove dynamic unit and just use hypercolumn and see how that performs. And if you use this code from the Kaggle kernel, that combines both of them and does it.
No, he has a switch where you can turn off at least the...
I think you can turn off only hypercolumn. You can't,
you can't do the reverse of just using the hypercolumn, but that should be simple enough to modify.
Absolutely.
It's just that it may not be a switch setting, but you might just have to...
You'll have to just rewrite this part of the architecture.
Exactly. Yeah.
Because my main goal is trying to squeeze how much I can out of a phone. Something as big as this becomes just impossible.
Right.
So that is something that I'm playing around with.
Okay.
So I'll let you know what the results on that is. That's pretty much all there is with hypercolumn. There's really nothing much there.
Okay.
If there is no other questions, then I'd like to kind of carry on like with my update and finish off.
Yes, go ahead.
Cool. A couple of things that I wanted to share with you guys was this concept of this loss function thing, which I was kind of struggling with, the cross entropy loss. Like, for example, when you build an architecture out, do you put a softmax at the end of it? Or like if you have, let's say this was a classification model, at the end of this, when you have like self.logits and you're basically storing the logits out, this logits is really something that you cannot directly use in your loss function, right? You have to convert that to a probability, and that probability is what kind of is used like with cross entropy.
Right, because you have the probabilities and the labels, not the because when we discussed it, I think last week, it's more like the batch size, then the channels which are actually the probabilities of each class,
Mm-hmm.
and then the H and W, correct?
Yep. So if you were to simplify that even more, if you write that out as a formula in cross entropy, you basically are doing this Y, which is this one hot value, right?
Correct.
And you multiply that into the log of the actual probability of prediction. This is what your model gives you back. Kind of important not to swap these two, because imagine if you end up with a Y hot inside the logs, then you're doing log of 0, and that's like not defined. So that's the way I kind of remember it. So this is what you kind of get. But then when you do, you're actually passing this logic to NN dot cross entropy, if you look at it. And I just kind of realized yesterday, after reading a bunch of other things, it kind of struck me that NN cross entropy actually does the softmax for you inside. So if you just pass in logit over here, comma target, where your target is actually one hot encoded. So I'm going to call that target one hot encoded. This logit, what happens internally is a softmax is applied. So this converts it to probabilities. And now you can compare probabilities and target one hot. I mean, not compare, you can use that to calculate your cross entropy.
One quick question when you're on it, because for other reasons that I'll get to in a minute, I was also kind of stumbling or trying to get into the same space to understand things better. So I have a question here.
Mm-hmm.
Here you took the, or as you illustrated, it takes the softmax, right?
Right.
Of the logic. Now, in the case of a multi-label multi-class, which means
Mm-hmm.
that you could have multiple classes like we have here, right? Because you could have class 1 and class 2 defect, which means it's multiple classes, and it's, or actually, which means it's multi-label, right?
Actually,
because the same image.
Different here, right? Because each pixel can be only one thing, right? Each pixel cannot have multiple classes.
Yes, that is, okay. So a pixel can only have a single class.
Exactly.
Okay, so because of that, it's a softmax and not a sigmoid.
Exactly.
Okay. But when it is a C, meaning at the level of the batch, what I went earlier, which is batch, class, then each class, that's more of a sigmoid, right? That is giving you the class level output, because then
right. So good point. Let's kind of go through that. I have kind of looked at that also. So you're talking of batch size. This is classes. Let's be more specific, or channels, right?
Right. Exactly.
And
then H and W.
H and W. Okay. So what happens now is this is the output that you would get from your unit.
Correct.
Right. Now what happens is, like, if you actually use this example back, you can make a lot more sense. You pass this is your logit.
Correct.
This is going to be logit, which goes back into this cross entropy. Now cross entropy is going to take a softmax, and the softmax is taken across the channel axis. So each pixel has like 4 channels, right?
Right.
And each pixel will give you four different logit values in these channels. When you take the softmax across the channel, so let us say you get values like 10, 20, 1, 0. These are the 4 values for, let's say, pixel 0, 0. Now, when you do the softmax, it's going to give you probability of each channel's existence or each class's existence for that pixel. So this will basically turn out to be, I'm just giving rough numbers here. So let's say that becomes 0.3 and this becomes like 0.8. And what is that now? Okay, that cannot happen.
Yeah, got it. Yeah.
0.6 and whatever the leftover stuff.
Yeah.
So now you know that it is the second class that is the most, with the probability of 0.6, that is, exactly. So that's the most likely one, that is it.
Yeah.
So this kind of took me a while to understand. And
that's very excellent, because I'll tell you why I was bumbling along with this was I was trying to implement focal loss, and focal loss just threw me for a loop with the implementation, and that's why I was struggling here of understanding, this precise, what does cross entropy do, what goes into it and what comes out of it, and how to modify it in order to get because again, this is cross entropy, so it's done at the level of kind of across the classes. But then when you get into focal loss, they start talking about, because in cross entropy it is still among the 5 classes which class,
Right.
that's what the channels and the class tell you, right?
Uh-huh.
But in case of focal, they go into the binary cross entropy, so it's like,
Right,
does this
right.
class exist versus no other class? Does class 1 exist versus
yeah,
class
correct.
1 does not exist?
Correct, yes.
Right? And class
Yeah.
1 does not exist doesn't, I mean, it's just it has no relationship with class 2 doesn't, class, I mean, it does, but what I'm saying is it's a binary choice of each
Yes.
class that's
Yes.
made.
Right.
And how to go from one space to another space and keep your things all straight is not trivial.
Right, I agree. So this is what, like I was telling, if you use cross entropy flat, you don't have to worry about this axis dimension. But otherwise, if you're actually using, this cross entropy loss flat is my custom cross entropy loss flat. And that's why you see that I pass axis is equal to 1. And that axis is equal to 1 is basically classes or channels.
Mm-hmm.
So I'm saying apply cross entropy loss flat, which is telling it internally that the softmax that you're going to be applying to the logits, apply it on axis 1, which is the channels.
Channels, right.
Right.
But isn't
this cross entropy loss flat, this is not the...
Yeah, this is yours, right? Because
Yes,
the cross entropy loss flat in Fast AI basically does what you had said earlier, which is just to the BC edge. If you go back to what you have there,
yes,
what it does is it keeps the classes or the channels, and then it combines H, W, and BS, all throws it all into one.
It just pulls out this to the end.
Correct. And
the
puts
rest of it
the rest in the first.
Right.
Yeah. Because then it can compare the same thing in the target.
Right, exactly. So that's what that is. So that brings us to like another question at the end of this is, so this is during training, right? So you have this loss calculation during training, you do all this, you're done, now you're deploying. Let's go back to a simpler case of classification. So let's say at the end of classification, you use dog image through ResNet 18 and you get some logit value. Now this logit value is just going to be numbers, right? They're not probabilities. So does that mean at the end of this, you need to kind of, after training and all that, you need to kind of stick a softmax in there, or you take the values and do a softmax? So the answer to that is like softmax, if you think of it, is just rescaling stuff, right? It's not changing the order of the numbers. So 10, 20, 1, 0, if you rescale it with a softmax, you'll still get this to be the highest. The second number will be the highest. The first number will be the next highest. And the last one will be the smallest. So you can get away by just doing like an argmax at the end, and that will still give you the same value. So you kind of save computation.
Because you are just interested in the index to the largest value, not the actual value itself.
Exactly. It's the same thing. It's just that probability is something that you can comprehend.
Between 0 and 1, when you are training, that matters. But as an index, you just care about capturing the right index to the right class rather than the value of that class.
Value of that class, right. And yeah, like, pertaining to your question, if any of, I assume you guys have kind of seen the Fast AI version 4 lecture, so where Jeremy kind of goes through the multi-category, which specifically the example of if you use a ResNet to detect given classes, you don't train it on something that it does not exist. So you train cats on dogs and you give it a donkey's image. It's not going to tell you it's not a donkey. It'll still tell you it's either a cat or a dog. So the way they get around with that is like what you were suggesting, where you use like a multi-category classification, but your loss changes internally. Your loss becomes the binary cross entropy. And the binary cross entropy loss is checking for each class, you're basically doing a sigmoid. And you check whether you get a probability for a dog, and you kind of scale that. Let's say you scale it and you'll get a certain probability. You'll scale for the next class, which is a cat.
And now you set a threshold, which is basically saying if it is less than this threshold, say none of these classes exist. And if it is greater than these thresholds, this class exists. And that is the same thing. I think if not familiar with the V4 one, if you go back to the version before that, I think it's very similar to the planets data set where you had like these maps.
The planets uses this multi-category
Exactly.
stuff. But I had a related question, and if it takes it away from the point you're making, then we'll defer it. But because I was struggling with this actually just yesterday, which is what's the quickest way to find what loss is used by FastAI for, for example, for dynamic unit? Because I was like, okay, I used to know this, but now I'm struggling because in the code, it depends, it seems, on the model or the type of categories that you have generated, at least in FastAI 2. And that seems, is that correct? And so should we chase the model code?
Right. So that's the thing with FastAI. Like it makes so many things work so smoothly that it becomes
you're lost in the abstractions.
Yep. So the way I kind of go about that is if you build your model, build your learner, and you can always call learner.loss function. So when you do learner.loss function, that'll tell you exactly what loss function you're using for which one.
So is it just a matter of printing it?
Yes, exactly.
Okay, that's what I was thinking of, but that's what I forgot. And I was like, okay, now I'm in the code, but there ought to be a simpler way to, I mean, I knew to change it, how to change it by giving it a new value, but I was like, what's your default value and how best to find it? So you just print the learner.loss.
Yeah, it's just a getter. So you can just do learner.loss function. So learner is basically this encapsulation for model, loss function, data, all that such as that. So you can just do a .loss, underscore func, I think. And it will tell you exactly what the function is. And there are certain places where you can kind of see that we were kind of investigating this at one point, and I remember like for the pets one, you go into this category block, which will call this categorize.
Actually, in fact, in the library code discussion, you can see, and we'll get into that either next week or the week after, where the categorize block, he defines the default loss, which is kind of where
it comes from.
And in the multi-category, he defines the binary cross.
Right, exactly. So that's where they kind of automatically sort of get set based on.
Exactly. Which is kind of deeply buried and,
makes it easy for someone who's starting, but I think when you start tweaking things, it looks literally like magic how things are coming.
Yeah, or at least when you have to decode, then it becomes a pain.
Yeah.
Or at least until you figure out what the easy way to decode, then it's.
Yep. Yeah, that's a painful experience. So that's why for my work I don't use FastAI, because there's so much of stuff that is like hidden deep there, and like the models work well. Because there are a lot more layers than there are conventionally there, so it becomes a lot more weights, a lot more parameters, heavier. So that's why I've been delving more into PyTorch, plain code, as well as TensorFlow. Which reminds me, the other thing that I tried this weekend was the what was that called? The library that Mehul shared.
Sorry, before we leave this.
Yeah, sure.
I've also been like looking at the loss functions. I was looking like at the F1 loss that Srinivas had said he'd used and it hadn't worked for him. So I looked at that, and I think the reason it hasn't worked is because of the fact it's for binary segmentation. It's not for a multi-class. And when you actually look at so your forward function and your loss function, it takes your target and it takes the prediction. On the bit where you had there, so the prediction comes in and it's batch size, number of channels, and then height and width. Whereas the y true value, the y underscore true, it isn't like that. It's not. It's like a single matrix. It's got dimensions of batch size, 1,
right,
height and width, because of the fact it's just the mask. So it's just like integers in a single tensor.
Right.
Whereas, so when you come to so you can see there when it does the TP one, the true positives or whatever, it's just multiplying y true times y pred but y true is just integers, and so like if your defect is defect number 3, suddenly it's multiplying by all of the
values in this
by each tensor, because like y pred has got like 5 tensors there. It's got like
okay. So ideally you should be comparing this class with each of these classes, like more of the, instead of intos, it should be like equal to sort of at each channel.
Yes, exactly. Yeah. And also as well, yeah, so like if it was the metric function, as you said, like there, rather than using the sigmoid, you would use softmax to get your probabilities. But if you actually want to get the classes and you want to drop your 5 tensors down to a single tensor, you would do the argmax on them. But you obviously you can't do argmax there in the loss function because it's not differentiable. So yeah, so I was looking to sort of find a way to be able to take the y true value and make it into 5 tensors, one for each of the other one.
I see. Okay.
But yeah, so like that's why it hasn't worked.
Right. Yeah, that makes sense.
That's good to know that that's the problem. May make more sense as I was. And since we are on the loss discussion, so my update I'll also is I tried to get the lowest loss working. And that one I did manage to get it working, and you know, it gave me and there are multiple settings. I'll post the code. In fact, I started off with the code from the writers of the paper, but it seems like it's a little bit dated, so I had to just tweak it a little bit and get it into the form that FastAI likes and stuff. But and a couple of places I had to make changes. But so I'll post it to see whether. But the net result of it is it gave me almost as good, but not quite as good result as the cross entropy loss. So to give you an example, I reached about 0.889 or 0.884 on the private score and 0.89 on the public score with the cross entropy loss. And the lowest loss gave me 0.85 on the private and 0.84 on the public. So it got up there, I mean, but obviously not as good, and which is what, whereas if you look at the paper, and I'll also post the link to the paper so people can look at it, and maybe we can discuss it in an upcoming session as to I couldn't find a quick easy way of summarizing the paper, but it just seems to say that lowest loss is piecewise approximate function that approximates the dice loss that is traditional, or the Jaccard loss, if you will, or the Jaccard score, which is converted into a loss, which is what this code that we are staring at attempts to do, but obviously wrongly, as Steve pointed out. But anyway, the lowest loss is apparently a approximation and is supposed to give better results. And it also has a couple of tweaks to it. And I played with the tweaks, which is, it only takes the loss of the images that are present in the batch versus taking the loss from all of the images and stuff like that. And then there's one other variant of it which does the loss calculation per image, I think, and that's the one I was trying to run when I ran out of cycles. But I'll post the link and the code that I tweaked and got working, and if people can take a look and at the paper, as well as whether there are things that are screwy with the implementation, that would be good. But it's interesting to me, at least, that while they've used in the paper, I think they used the Cambridge or the related data set and show improvements, at least in this instance, barring one tweak, which I haven't gotten the results for for the other two cases, it doesn't seem to give better score than just plain cross entropy.
Is there anything to do with like number of epochs? Do you need to kind of increase that, or? I've not read the paper, so I'm just curious.
Yeah, no, I mean, good question. Ultimately, that's a good question. I haven't tried. I just tried to keep it the same. I ran about 20 epochs or 15 plus 4, about 19, 20 epochs total on the cross entropy. So I tried to do the same with this. And the cross entropy results I'm reporting are about 20 epochs. And this also, I ran 20 epochs. My recollection from the paper is they don't seem to say that it requires less or more compared to the traditional.
Okay.
But it's a good question. I mean, I haven't, and the 20 epochs takes about 8 hours or so, for 7 to 8 hours with the tweaking. And remember that, in order to then subsequently score, you have to go through another notebook and then another notebook. So all that takes another hour or so. So it takes about 9 hours circle time. So I can only do about max of 3 experiments in a week.
Yeah, I moved away from Kaggle. I'm doing it all in Colab to get around that.
Okay. I in fact started in Colab with the protein atlas, and then the data thing was so big, and I should go back to setting it up, because each time you change, you have to kind of go and set it all up. And
yeah, the steel one, I just copied over the tiles or whatever, and so it's not very big, so there's not as much data to shift about. And yeah, like obviously as well with Colab, you can save your results, which you can't do with Colab, and you haven't got the limit of the 30 hours or whatever.
Yeah. That's
so
true.
yeah.
Oh, sorry. That reminds me of another thing which I was reading. We were discussing about Colab having issues with data, right? Like if you're trying to bring in a folder with tons of images, it just crashes or it just times out.
Yeah.
There was something that I was reading which people were suggesting, why don't you just compress everything, do a Git commit, and then pull from Git, and then unzip it. And then that should work. That was one strategy someone was saying. But then again, there are limitations on zip sizes and how much you can push on Git. So if that works, maybe that's an option for you guys. The other thing that I was reading was the delay, because it takes forever for me to, like if I point to a data set in the drive, it takes forever to read those images the first time and then it caches it. That again, someone was suggesting, instead of doing it multiple times, go into your folder and then just do a copy, which is that CP, and you give source and destination and bring it into Colab's content directory and then just leave it there. So basically, if you're experimenting on that day, or everything sits in content, and obviously once you close your session, then kind of gets lost, but you don't have to do it like multiple reads.
That's the way I did it. I copied the zip file over to Colab and then unzip it locally.
Okay, cool. Okay.
Yeah, because it's too slow going back to drive all the time. But it takes a couple of minutes for the steel data. It takes about 2 minutes to bring it over, so it's not too bad.
Actually, the human protein, the only thing is the human protein atlas, I got a bigger size storage in Colab and paid for it and got it. I downloaded, the downloading part took a while, but it's, as he was saying, even 20, 40 gig was like, I don't know, maybe 10 minutes once, but that isn't the problem. Unzipping just doesn't work.
Right. So that's what, that I don't think this would be a solution for. This was kind of an intermediate Colab solution, I would suggest.
Yeah. So I think for this, as Steve says, I should just overcome my setup hassle and just go do it once, and then I should be set up on Colab again. So.
Yeah, it took me about a week to get everything sorted and set up, but yeah, like now it's all fine. That means I can work on it.
Everything is working, and then when you switch, then you have to go back and figure all that stuff out again.
Yep.
Yeah, I think I've mentally decided I'm not going to submit for this competition because there's just too much hassle and way too many experiments that I want to perform. So I'm just going to create one test data set and just keep evaluating on that for my experiments.
Yeah, so this loss thing, I'll post the code, and so Lowest loss, interestingly, is a good, experiment that I was able to get successfully working, but obviously it still doesn't yield better results than And so, if we can, to Steve's point, if we can collectively figure out how to make the F1 or this dice laws multi-class, and then it would be even more interesting to compare that to the LOAS laws. But the LOAS laws, I'll post the code and the paper link, and take a look, and we can discuss the more of what is actually happening. Which is the reason I was but in fact, the first thing I wanted to try was the focal laws. But then the focal laws implementations I found didn't quite work, and that's why I was.
Is focal loss there in PyTorch? I'm pretty sure it's there, right?
Oh, it's there even there are versions in the documentation in Fast AI of so-called multi-class focal loss.
Okay.
But unfortunately, I am just getting nans and, not
cool.
a number.
Cool. I'll just give that a try because from theory, that should just be an scaling factor for the cross.
Yeah, exactly. That's what it appears, but that's invariably you'll find that's for the binary case. So the multi-class, I just found one implementation, and that's the one that just dies.
I see. Okay.
For me at least. So if you can get it working, that'd be interesting too.
Yep.
Yeah, so I've taken your function here and tried to make it multi-class. It's actually running at the minute, but I don't think it's quite right yet. But I think it's better than it was, but there's still a problem. I'll post that up as well because I'll let you see what I've done, and you might be able to spot what's wrong with it.
Okay, great. So that's my update done as well for the week. So.
Oh, sorry. The other thing that I just wanted to add was I got the. This is going back to the problem that I had because I was not able to convert a PyTorch model to CoreML.
The mystery that it was giving different results.
Yeah. So I switched back to TensorFlow, and it not really worked in that. But then the library that Mehul had shared, which had all these bunch of segmentation stuff that you could just pip install and then change your backbone and change your loss and all that. They have an example in PyTorch and in TensorFlow. So I managed to get that running. So I have a TensorFlow version which runs Camvid right now. So I'm planning to change that also and see if you do exactly the same thing, how much of a difference, like, are you guys all deep learning like starters from FastAI, or have you guys done something before FastAI?
Before FastAI, I was using Keras.
Oh, okay.
So I looked at like TensorFlow a little bit. I liked Keras. It was good because it was like a high-level version, but yeah.
Right.
And then switched to FastAI just because of the courses, really.
Yeah, I don't know the pain of that that Jeremy keeps pointing out compared to FastAI. So doing that is going to kind of give me the experience of how much easy FastAI is supposed to make your life, sort of a thing. So
as you say, though, it's like FastAI sort of covers everything up. It does a lot for you.
Right, exactly.
Whereas if you do the other things, you
all
sort
the great stuff is not there. Yeah, right.
Yeah. So I started, in fact, in TensorFlow way back and did, in version 1 of TensorFlow, not even with Keras, and then I moved to Keras a little bit later. And strangely enough, the last year and a half, I've completely switched to PyTorch as I migrated to FastAI, and then now I'm, and the other thing which is, it was, I could tell that it was much more of a pain having started there of TensorFlow because of all this setup it required and things like that. I mean, it wasn't closer to Python, and it was the version 1 had the graph thing. It wasn't like dynamic evaluation and stuff. So you had to do much more to get it to work the way you wanted to. And Keras, while somewhat better, still I felt when I switched to PyTorch that it was, if you know Python, it made it so much simpler. But now PyTorch has caught up with its changes in version 2. So I think now the differences are much smaller. So I'm hoping this, the HOML course, as we get into the PyTorch things, will re-expose me to the PyTorch that I need to recall but with the version 2 underneath, so that it's a lot simpler.
Great.
I'm using Keras 2 at work right now, so it's no problem at all. Like,
Nice. Okay.
yeah, it's nice. Like it's the same thing, right? Like we spent like we are classifying body images, like it's all over. So we have MR. We have 5 modalities: MR, X-rays, ultrasound, PET, and CT, and all parts. So brain, liver, spleen, blah blah. Like, so we have right now we have 250K images, labeled images, and it's the same problem. It's like preparing the data took like 6 months, and Keras is like maybe a week to run the model. Yeah, someone. So I was telling you, like, someone left. So they actually started. They're doing transfer learning, and they picked MobileNet.
Okay.
And I was like, why did you pick MobileNet? But it just works.
Yep, I'm using MobileNet for my.
Yeah.
The accuracy is low, but that's the weights are so much more smaller.
And there's this one guy on Kaggle. He has this really nice transfer learning Keras models. He makes. I think he's a professor somewhere in Zurich, and he has this incredible. Like, he has one for the object detection for lungs. So he has done something really nice. Like, you can just pick any pre-trained model within, like, VGG, any of the ResNets, blah blah blah. I'll post a link to his notebook. It's a really nice notebook. Just to get you started with all the Keras stuff. And oh yeah, of course. And the best thing about Keras right now is, like, I mean, PyTorch has it too. Like, both of these have, like, the data generators. I love the flow from data frame, because so the guys who prepared the data, they spent 6 months, and in the end they gave me a data frame, right? So I don't want to do flow from directory or flow from folder. I want to do directly flow from data frame, and especially since I have access to, like, one decent GPU at work. It's a single GPU RTX 2080, and it is like that. I thought the flow from data frame will be slow, because the person before me was loading things into NumPy arrays, and even flow from data frame for 80,000 images, like size 256 by 256, is only 3 minutes or 2.5 minutes. Just going through one epoch. But yeah, Keras has been I don't. Yeah, it's been fine. Like, Keras 2 is okay, but now I'm going to look for a job in 6 months. Like, okay, just learn both.
Mehul, quick question. So Keras, when you say you're running it on top of TensorFlow 2?
Yeah.
Okay.
Yeah, and now they are, so, and the other thing that tripped me up a lot is, before you would do import Keras, and you'd say from Keras import blah blah blah, right. But now it is from tf.keras, and it's that now it's like the official API. So now you have to do so that thing is, like, nasty, because when you search, sometimes you get the old Keras and sometimes you get the new Keras, and they are not synced up. So that way PyTorch is better. It's at least when you search, you will find one thing and not multiple.
The transitioning phase is not okay. I see what you're saying.
So yeah, if you can post the library, and what library had you posted earlier that Rekil you were referring to? Maybe you can.
That's the segmentation one. I can pull that. I'll share that.
Yeah, if you can repost it. That's the thing. I, in fact, wanted to talk to Sam sometime to see whether we can get all our channels on Discuss, and if he can fork over the one-time $300 fee or something, because that is much more. It makes it like the forums that Fast AI has, rather than this Slack channel thing. So I've been meaning to wanted to raise.
Search. Everything is so much more easier with that.
Yeah.
Oh, it's only a one-time fee. It's not like a subscription.
It is a subscription of $5 or $10 a month, but $10 a month is $120 a year. So that is not so bad, but the open source version for just deployment, not support, or not ongoing support, but just getting it set up for you is, I think, $300 or something.
I see.
300, yeah, I think $300. I looked into it because I was getting frustrated with the Slack, and I was like, how much will it cost? And if we did that, and it's about $300. So anyway, I've been meaning to send Sam a note saying, hey, is that doable? And then maybe he can ask around for, some of us can fork over for the maintenance part of it every year. That would not be too bad. But if we can put the first cost of just getting it set up, then the rest should be relatively simple. But anyway, let's see.
One more note, like when we were talking about the loss function and the cross entropy and taking the softmax. So I stumbled across a thing about, like we have these probabilities, and I always assume like that, okay, the probabilities are good, they're interpretable and they're good. But there's a big there's some couple of, like I saw some discussion about calibration of these probabilities. So the probability says 0.99, but it doesn't mean anything.
Right.
It's
not a true probability in that sense.
Mm-hmm. And so this, I don't know if anybody's looked at so I was searching, but I haven't. So the reason I came across this issue is that we have there's a paper reading study group I sometimes go to like once a month. They only do reinforcement learning, so I don't like reinforcement learning. But sometimes so this time they picked a nice paper from one of the oral papers from ICLR, and so it's kind of related to our work. It's like it's talking about why like your class. I just shared the link. Your classifier is an energy-based model, and it talks about using those logics to predict the. Are we over time?
It's okay. I mean, we started at 11, so it's a little over, but we're just
okay.
So if we have the time, we can go on a little bit longer.
Okay. I'll need to head off soon, but we can hang around for about 10 more minutes.
Okay, I'll finish in 2. So he basically, so exactly what we have been talking about, right? Like you have your classes, you have a neural network, you have your logics, and we are passing it to the softmax, and we compute the posterior. So P of y given x. So he in this paper and code, and I got a headache after reading that paper and that study group. He talks about that that you can from these logics, if you do some simple transformations, and you can get you can get the prior of your classes. You can and then from this he can, sorry, this is too hand waving, but this is where I saw the calibration problem. So one of his motivations for this, oh, it's not here. Shoot. Maybe it's at the, one of the motivations for this paper is that the softmax, after softmax, there's a calibration problem. But just a note, that's where I saw this thing about calibration. He has he has a pseudocode, but okay. Anyway, we really, like, for 1.5 hours, there were like 6 of us, and we were just struggling through, just look at his pseudocode to understand what the hell he's doing. But it's,
that's interesting.
Yeah. But anyway, okay.
That's it. So let's try to if Steve can post, I'll post the Loas softmax modifications I made to the reference code I roll off the paper implementation guys stuff, and then let's get back next week to see what whether any improvements are possible from the base level of stuff that we have now working. Okay.
Okay.
Sounds good.